Today, we'll interpret and compute division of a fraction by using a fraction. I want you to start by grabbing a piece of paper and draw a model that represents 12 divided by 3. Okay, so here's 12, and I could say in one hand that 12 divided by 3 is how many 3's are in 12. And so my model would look something like this. There are 4 groups of 3 in 12. 12 divided by 3 is 4. But remember that there are two different ways to look at division problems. One is measurement division and the other is partitive division. We just used the measurement method, so let's now try partitive division. And that would be 12 divided by 3 would be saying 12 is 3 groups of what size? Okay, 12. I can make 3 groups, 1, 2, 3. Now what size are those groups? Well, there are 4 in each group. 12 is 3 groups of 4. That's partitive division. Take a look again at the way that we first did this division problem with measurement division. I want you to write a question or a word problem that matches this kind of model. I came up with 12 balls are put in groups of 3. How many groups are made? You see, within that question, I'm asking how many 3's are in 12. The answer, of course, would be 4. Now I want you to use the partitive method that we did before and create a question or word problem that matches that model. And I came up with here, 12 cards are shared with 3 people. How many cards does each person get? You see, in this case, I am asking 12 is 3 groups of what size? 12 cards shared with 3 people, what size, or in this case, amount, do each person get? Okay, ready for some quick math? Go. 8 divided by 2, what is it? Yes, 8 divided by 2 is 4. Whether we do it measurement way or partitive way, it's going to equal 4. What about 8 ones divided by 2 ones? What would that be? Yeah, 4, right? 8 ones divided into groups of 2, or how many 2 ones are there in 8 ones? There are 4. How about 8 tens divided by 2 tens? Yeah, what do you know? It's 4. Ooh, what about 8 thousands divided by 2 thousands? You guessed it, 4. Why? Well, if we drew out 8 thousands and we started taking away 2 thousands at a time, we would do that 4 times. Ooh, but let's move into fractions. How about 8 tenths divided by 2 tenths? What do you think that'll be? Yup, 4 again. But let's do a tricky one now. 8 thirds divided by 2 thirds. Ooh. Yes, if I have 8 thirds and I'm taking away 2 thirds at a time, I will be left with 4. Why is it that the quotient of each of those problems was 4? The reason we have the quotient as 4 each and every time is because the units are the same. 8 divided by 2. Whether they're thousands or thirds or hundreds or fourths, it's still 8 somethings divided by 2 somethings. And that will always give us 4. So let's actually look at this a bunch of different ways. 8 ninths divided by 2 ninths. Can you write this out in unit form? That means using words. It looks something like this. Here's our units, our 8 and our 2. That's why it's called unit form. The rest is just written in words, ninths. And we know from our pattern that 8 ninths divided by 2 ninths is going to give us 4. We also remember from last time that when we divide fractions, we can multiply the reciprocal and get the same answer. So instead of saying 8 ninths divided by 2 ninths, we could say 8 ninths times the reciprocal, 9 halves. And so we can then multiply the numerators and get 72, multiply the denominators and get 18, and that can be simplified. Both can be divided by 9. 72 divided by 9 is 8, and 18 divided by 9 is 2. So we'd have 8 halves, which can be simplified again. We can divide both by 2 and end up with 4 over 1, which we know is 4 whole 4. 8 ninths divided by 2 ninths, or 8 ninths times 9 halves, is equal to 4. But lest we just leave these numbers floating in our minds, let's take a look at what this would look like. So here's 8 ninths, right? And we want to know how many 2 ninths can we take from 8 ninths. So I'm going to start grabbing 2 ninths, because there are 2 right there, and 2 there, and 2 there, and 2 there. So the question is, how many 2 ninths can we take out of 8 ninths? And yes, once again, no matter what strategy we use, the answer is still going to be 4. Okay, new problem. 9 twelfths divided by 3 twelfths. Of course, written out in unit form would be written like this, 9 twelfths divided by 3 twelfths, which I hope by now that you realize the answer will be 3. 9 anything divided by 3 anything is going to give us 3. But what does this actually look like drawn out? What is happening behind the numbers? Well, let's draw out 9/12. Now notice I drew 12 boxes, but I only captured 9 of them. Why? Because it's 9/12, 9 pieces out of 12 that make a whole. And we're wanting to know how many of 3/12 there are. So I can capture 3/12, and there's another 3 and another 3. And so we realize that there are 1, 2, 3 groups. 3 groups of 3/12 inside of 9/12. Let's try another one. How about 7/9 divided by 3/9? So, okay, we can do this one unit form as well. 7/9 divided by 3/9. Oh, wait a minute. I can't do that. All right, let's draw this one out. Okay, here's my whole. But because we're dealing with ninths, I'm going to draw 9 pieces, right? 9 make a whole. But in our problem, we're only dealing with 7/9. So there they are. There's 7 of my ninths. And we want to know how many 3/9 there are. So there's 3/9 there, and there's 3/9 there. Oh, but notice my last set of 3/9 is more than my 7/9. I can't take that because there isn't that 3/9 inside of 7/9 there. Take a look. The yellow section, right? There's 3/9. The red section, there's another 3/9. But that blue is only 1. 1 of what? 1 of something that makes a whole. Well, what are we taking away? We're taking away 3/9. So every 3 blocks makes 1 whole. If every 3 blocks makes 1 whole, then I have 1 whole there. Another whole time we can take 3/9 there. But this last piece is not a whole, is it? We need 3 to make 1 group of 3/9, but we only have 1. And 1 out of 3 is 1/3. So if the question is asking how many 3/9 are there in 7/9, we can say that there is 1, 2, and a third. 2 and a third 3/9 are inside of 7/9. How about this? How many fourths are in 3/4? We can write it out. Numbers like this. We can show it like this. How many fourths are in 3/4? Okay, here's my whole, but we're dealing with 3/4, so I need to cut it into 4 pieces, but only take 3 of them, because that would be 3/4. And the question is, how many fourths are there? All right, I need to start counting fourths. There's a fourth, there's a fourth, there's a fourth. So 3/4 divided by 1/4 is 3. 1, there's 1 there, 1 there, 1 there, 3 of them. And let's check this. Can we flip it and multiply by its reciprocal? 3/4 times 4/1? Well, that would equal 12 on the numerator and 4 on the denominator, and we'd simplify that to equal, it'd equal 3. Okay, new problem. How about this? 4/5 divided by 2/5. Okay, let's draw it out. Where's our 4/5? Well, let's start with fifths. So here's the 5 that make a whole, but remember we only want to deal with 4/5. So here's my 4/5. We want to know how many 2/5 there are. Okay, within my 4/5, I see 2/5 on the left and 2/5 on the right. Perfect. There's none left over, and it works out nice and evenly. So I have 1 group of 2/5 and 2 groups of 2/5. So how many 2/5 are in 4/5? 2. How about this? 9/4 divided by 3/4. 9/4 divided by 3/4 equals 3. Oh, how do we know that? Well, notice that they have the same amount that make a whole, right? They both take 4 to make a whole. That's the denominator. And because they're the same, we know that if we want to take out 3, we don't have to break any up or do anything weird. We're just going to take 3, 3, 3 until we reach 9. And it just so happens that 9 divided by 3 is 3. Remember? Whether it's 9/1000 divided by 3/1000 or 9/3 divided by 3/3, it will equal 3. How about 7/8 divided by 2/8? Try this one on your own. Okay, so I drew out 7/8 and I started taking away 2/8 at a time. 1, 2, 3, but then I noticed I only had part of another one. I had to figure out how much that part was, and I noticed that it takes 2 of them to make a whole, so that's 1/2. So I actually have 1, 2, 3.5 2/8 that make up 7/8. 7/8 divided by 2/8 is 3.5. How about 13/10 divided by 2/10? Here's my whole. Now, in this case, 10 make a whole. 13/10, right? 10 make a whole, but I need 13 of them. So I'm going to draw 13 boxes. label it 13/10, and start finding how many 2/10 there are. Okay, I can make groups of 2/10 like this. Then I can count how many groups of 2/10 I have. 1, 2, 3, 4, 5, 6. And one piece that doesn't have another partner, right? It needs 2 to make a group, and I don't have that. So this 1 by itself is actually 1/2. It's half of a group of 2/10. So all in all, we have 1, 2, 3, 4, 5, 6 and a half. How many groups of 2/10 are in 13/10? 6 and a half. Or we can say it this way: 13/10 divided by 2/10 is 6 and a half. How about this one? 11/9 divided by 3/9. If you did this problem correct, you would have found out that you'd have 3 whole and 2/3 left over. So 11/9 divided by 3/9 is 3 2/3. Here's today's summary. What we have done is we've learned that we can divide a fraction by another fraction, and it makes it nice and easy if they have the same denominator, the same number that make a whole, because then we can just scoop them out one at a time, and if there isn't enough, we can figure out what fraction that is of the groups we're looking for.